And welcome to Technology Tap. I'm Professor J. Rod. In this episode, we're going to do CompTIA Core 2 supporting Windows. Let's tap in. Welcome back, friends. This is Professor J. Rod, and welcome to Technology Tap. For those of you who don't know me, I'm a professor of cybersecurity, and I love helping students pass the A+, Network+, and Security Plus series of exams. Every now and then I throw a little history there. I'm a wannabe amateur historian, and I like to talk about the history of computers, technology, computer companies. So if this is the first time you're here, welcome. If you want to reach me, you can email me always as Professor J-Rod, that's J-R-O-D. If you want to reach me at TikTok, I'm at Professor J-Rod. If you want to reach me on Instagram, at Professor J-Rod. If you want to reach me, the Facebook is Technology Tap Podcast. All right, this is not a lecture about tools. This is not a memorization session. This episode is how technicians think when things break, and more importantly, why they think in a specific order. Because real users don't say, my DHCP least failed, DNS resolution is broken, my OS failed during post. They say, nothing works, the internet's broken, it was fine yesterday. Your job is to take emotional input and turn it into technical certainty. And that process always begins the same way. Before Windows can be fixed, updated, accessed, or repaired, it has to do one thing successfully. It has to communicate, not load apps, not open a browser, not show Wi-Fi bars. Communicate. That means the operating system must be able to identify itself on the network, understand which devices are local, know where to send traffic that isn't local, translate human readable names into network addresses. If Windows cannot do these things, then authentication fails, cloud application fails, update fails, remote support fails. Not because those services are broken, but because Windows cannot reach it. This is why networking is always step one, even when the problems doesn't sound like networking. A browser only answers, can this application reach service? That's too late in the chain. A technician starts earlier and asks, does this system have a valid network identity at all? If the answer is no, nothing above that layer can work. This is why we always go to IPConfig. IPConfig is a command line command. So why does IPConfig exist, and why does it come first? It exists to answer one foundational question. Was Windows successfully accepted into the network? When you run IPConfig on the command line, you're not checking settings, you're verifying identity assignment. For Windows to participate in a network, 4 conditions must be true, not optional, but structurally. A valid network identifier requires an IP address, who the system is, a subnet mask, where the system belongs, a default gateway, how the system leaves its local network, and a DNS server, how the system translates names into destinations. These are not conveniences, they are requirements. If any one of them is missing or incorrect, communication does not partially fail, it collapses. This is why IPConfig is always first, not by habit, but by necessity. Once the IP information is visible, the technician immediately asks, was this system supposed to get the identity automatically, or was it manually configured? The question matters because it determines where the failure is allowed to exist. If the system is using DHCP, Dynamic Host Configuration Protocol, Windows is saying, I asked the network who I am. If that request fails, the problem cannot be the browser, the application, or the website. The failure must exist somewhere in the network infrastructure. If the system is using a static IP, Windows is saying, a human told me who I am. And if that information is wrong, the failure is not on the network, it's on configuration. This single fork eliminates half of all possible causes immediately. If IPConfig shows an address in the 169.254 range, Windows is communicating something very specific. It is saying the network adapter is functioning, the TCP IP stack is intact, the operating system is healthy, but no DHCP server responded. This allowed the technician to stop suspecting the NIC, the OS, and the cable and focus on the router, the DHCP servers, and network segmentations. That's why CompTIA test APIPA. It proves whatever you understand what Windows is telling you. Once Windows has an identity, the next question becomes, how far can this system communicate before it fails? This is where ping is used, not randomly and not to test the internet. Each ping answers a different diagnostic problem in a strict order. First, the loopback address, 127.0.0.1. You ping that. So you go to command line and you ping 127, you type in ping space 127.0.0.1. This asks, can Windows talk to itself? If this fails, the problem is not the network. It is the operating system. Next, the local IP address. This, again, by doing IPConfig. You go to the command line, you type IPConfig. This confirms the NIC driver and the interface binding, then the default gateway. This is the moment the traffic attempts to leave the local network. Failure here points to router or firewall issues. Finally, a remote IP address. If this succeeds, routing is confirmed. At this point, the numbers work. DNS does not create connectivity. It creates usability. This is why NSLookup comes after IP-based tests. When a technician says IP works, but the names don't, they are stating the routing works, the connectivity exists, name resolution is broken. This is reasoning, not memorization, which is why CompTIA uses DNS scenarios. Even with IPS and DNS working, a service can still be unreachable. Services live on ports. Example, web traffic for TCP unsecure and secure websites. For secure networks, it is TCP 443. For unsecure networks, it is TCP 80. For file sharing, it's port number 445. For remote desktop, it is 3389. When technicians use the command Netstat on the command line, they are asking, is anything actually listening where it should be? If nothing is listening, the network is not the problem, the service is. At this point, the problem is no longer whatever Windows can talk. The problems become, can I access the system in a way that allows me to fix it? This is where many new technicians jump too quickly to tools. Experienced technicians pause and ask a more important question first. Before choosing how to connect, the technician asks what level of access is appropriate for this solution, because remote access is not neutral. The moment you enable remote access, you are exposing services, opening ports, increasing attack surface, introducing credential risk. So remote access is not about convenience, it's about controlled power. Remote desktop protocol, port number 3389, exists to answer a very specific need. How can an administrator fully control Windows system from a distance as if they were sitting in front of it? That level of power requires session replacement, credential-based authentication, direct access to the OS desktop. Because of that power, RDP listens on well-known ports. Opening TCP 3389 means the system is discoverable, authentication endpoints are exposed, brute force attempts becomes possible. This is why RDP is disabled by default. Not because Microsoft forgot, because exposing that port without intent is dangerous. If 3389 must be opened, the next question, at what point does authentication occur? Network level authentication forces credentials to be verified before a remote session is created. This matters because without network level authentication, a session can be partially established, system resources can be consumed, and attackers can probe the service itself. When CompTIA mentions NLA, they're not testing a checkbox. They're testing whatever you understand pre-authentication risk. If the user is actively working, watching what you do, learning from the interaction, and not meant to relinquish control, then full desktop takeover is unnecessarily risk. This is why a second category of tools exists. Remote access answers a different question. How can I help a user while they remain in control of the system? Remote assist is user initiated, is time limited, requires explicit consent, can request control rather than assume it. Under the hood, it still uses port number 3389, but ramped in consent and session boundaries. Same port, completely different security posture. That distinction is intentional. Graphical access is not always required. Sometimes the question is not, what does the user see, but how do I manage the system at scale? This is where command line remote tools exist. Windows Remote Management exists to allow scripted management, configuration changes, remote administration without GUI exposure. WinRM uses port numbers 5985 for HTTP or 5986 for HTTPS, which is the one that is preferred. The secure port matters because credentials are transmitted, and if you use 5985, you're transmitting it in clear text. WinRM is not about helping one user, it's about managing many systems reliable. SSH exists to provide secure, encrypted command line access. It listens on port number 22. SSH matters because it solves a problem Telnet, port number 23, never could. Credentials are protected, sessions are encrypted, and identity can be verified. When CompTIA mentions secure command line remote access, they are testing you, whatever you understand why encryption matters, not just port numbers. At this point, users often ask, see, it's slow. See, it freezes. See, something's wrong. But experienced technicians do not troubleshoot feelings. They troubleshoot evidence. Performance tools exist because human perception is unreliable. System fails in patterns. Bottlenecks leaves fingerprints. The first question is not, why do you think it's wrong? It is, which system resources is under pressure right now? Task Manager answers that question immediately. It shows CPU usage, memory pressure, disk utility, and network throughput. Each tells a different story. High CPU means computational delays. High memory means paging. High disk means I/O contention or failure. High network means congestion or data movement. High usage is not failure by itself. Context is everything. Performance tells you what is happening now. Event Viewer tells you what happens before the failure. Logs are not opinions, they're timestamps. System logs point to drive failures, power issues, OS instability. Application logs point to crashes, dependency failures, misconfigurations. Security logs points to authentication problems, access violations, policy enforcements. If CompTIA says unexpected shutdown, system crashes, service fails to start, they are testing whatever you know where the evidence lives. Resource monitors exist to give deep, immediate snapshots, process level visibility. Performance monitor exists to track trends, prove recurring issues, and capture long-term behavior. One answers, what is happening now? The other answers, has this been happening for weeks? At some point, the technician must ask, am I troubleshooting the system I think I am? System information answers that. It reveals BIOS versus UEFI, driver versions, firmware state, hardware capabilities. Misidentifying the systems leads to misdiagnosis. Eventually, a technician encounters the worst case. It won't boot. This is where inexperienced technician reinstalls. Experienced technicians slow down. You cannot fix what you don't understand. The boot process tells you where the failure occurred and which recovery tools apply. BIOS systems use MBR, Master Boot Record. UEFI uses GPT and Secure Boot. Treating them the same causes damage. WinRE, or Windows Recovery Environment, exists to recover Windows without destroying user data. It provides startup repair, system restore, command prompt, and reset options. These tools exist in an order for a reason. System restore rolls back your drivers, registries, and updates without touching user files. Reinstalling Windows before attempting restore is not troubleshooting, it's surrender. Blue screen of death are not random. Stop codes indicate kernel failures, driver conflicts, memory corruptions. Writing them down turns panic into a diagnostics. All right, it's time for the 4 multiple choice questions. And this is how I do it. I read the question and then I read the choices that you give me and then I read them again. And then I give you what the answers. But I also give you 5 seconds before I give you the answer. So here we go. Question 1. A Windows system displays an IP address 169.254.34.11 when IPConfig is run. The user reports that nothing works. What is the most accurate interpretation of this information? A. The network adapter is defective. B. DNS resolution has failed. C. The system failed to contact a DHCP server. Or D. The default gateway is unreachable. I'll read it again. A Windows system displays an IP address of 169.254.34.11 when IPConfig is run at the command line. The user reports that nothing works. What is the most accurate interpretation of this information? A. The network adapter is defective. B. DNS resolution has failed. C. The system failed to contact the DHCP server. Or D. The default gateway is unreachable. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The correct answer is C. An address in the 169.254 range is an APIPA address assigned automatically by Windows when no DHCP server responds. This tells the technician several important things. The network adapter is functioning, the TCP/IP stack is working, and the operating system is healthy. What failed is identity assignment from the network. Because of this, the technician should not troubleshoot browsers, application, or DNS first. The current focus is DHCP service, router, or network infrastructure. Question 2. Why is IPConfig the first command a technician uses when troubleshooting Windows network issues? A. It verifies internet connectivity. B. It confirms application level access. C. It validates whatever the system has a network identity. Or D. It checks which ports are open. I'll read it again. Why is IP the first command a technician uses when troubleshooting Windows network issues? A. It verifies internet connectivity. B. It confirms application level access. C. It validates whatever the system has a network identity. Or D. It checks which ports are open. I'll give you 5 seconds to think about the answer. 5, 4, 3, 2, 1. The correct answer is C. It validates whatever the system has a network identity. IPConfig does not test the internet or applications. It verifies whatever Windows has the 4 required components of a network identity: IP address, subnet mask, default gateway, DNS server. Without these, no higher level service can function. This is why technicians start with IPConfig, not by habit, but because it determines whatever any troubleshooting is meaningful. Hope you got it right. So far, are we 2 for 2 yet? Yes? All right. Next. All right. Question 3. A system can successfully ping a remote IP address, but cannot access websites by name. What is the most likely cause? A. Routing failure. B. Firewall blocking ICMP. That's ping. C. DNS resolution failure. Or D. Incorrect subnet mask. I'll read it again. A system can successfully ping a remote IP address, but cannot access websites by name. What is the most likely cause? A. Routing failure. B. Firewall blocking ICMP. That's ping. C, DNS resolution failure, or D, incorrect subject mask? I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The correct answer is C, DNS resolution failure. Successful communication with a remote IP address proves that the system has a valid IP address, routing is functional, the network path exists. Failure to resolve domain names indicates that DNS is not translating names into IP address. This is the exact scenario where a technician uses NSLookup because the issue is not connectivity, it is name resolution. All right, last question. See if we're 4 for 4. A technician enables remote desktop on a Windows system. Which port must be accessible for remote desktop connectors to succeed? A, port number 22. B, port number 80. C, port number 445. Or D, port number 3389. A technician enables remote desktop on a Windows system. Which port must be accessible for remote desktop connections to succeed? A, port number 22. B, port number 80. C, port number 445. Or D, port number 3389. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the correct answer is D, port number 3389. Remote desktop protocol uses TCP port 3389 by default. Opening this port allows full remote desktop access, which is why RDP is disabled by default. And network level authentication is strongly recommended. This questions test whatever the technician understands that remote access equals exposed services, not just convenience. Now, the one thing about port numbers, there's a certain number, it's like 20, 25 port numbers that you have to memorize for the CompTIA exam, the A+ exam. The good thing is that once you memorize them, when you go to Network Plus, Security Plus, Cloud Plus, they're the same ones. So if you memorize them here, which is the foundational one, you never have to worry about it going to a different, having to learn anything new. Like I said, 50% of Network Plus is an A+, and about 30% of Security Plus is an A+. This is why we don't jump ahead. This stuff scaffolds. Do A+, do Network Plus, do Security Plus. Do you need to do Tech Plus? Probably not. If you want to be a help desk technician, you probably don't need Tech Plus. I think Tech Plus is for, like, you're in accounting and you need somebody in the accounting group to know a little bit about computers. That person will be Tech Plus. Maybe marketing person, same thing, right? You need somebody there to be Tech Plus. If you're going to run an MIS, you probably need Tech Plus, right? But you don't need the rest. So that's going to be my next podcast, guys, is the Tech Plus, doing all the chapters from Cert Master or Test Out, whatever CompTIA uses these days, and taking those and making those chapters and making them into a podcast for Tech Plus. This one, I know we talked about DHCP and we talked about DNS, but I think I didn't spend a lot of time on it, and I'm going to do kind of like a deeper dive on DHCP because I have a whole song and dance that I do in my class. I'm going to try to translate it here in this issue. I think I may have attempted to do it in an earlier episode a few years back, but I think I'm gonna bring it back up so that way you guys can see it. It's kind of, it's a unique way of stories. Some people don't like it. Some people do, some people don't. If you're not really from, that have that background that I use to describe the HCP, some people get turned off by it, to be honest. I'm looking at you, Penn State. All right, let's wrap this up. Good troubleshooting is not fast. It is deliberate. What we've done across this episode is something many people skip. You learn why the orders matter. You didn't start with tools. You didn't start with dependencies. You didn't guess. You eliminated uncertainty layer by layer. You proved whenever Windows can communicate, whenever it can be reached safely, what the system was actually doing, and how to recover it without panic. That is not just how you pass CompTIA A+. This is how you earn trust as a technician. If you can explain why you chose a command, you would always find the right answer on an exam or on the job. All right, thank you for listening for this episode of Technology Tap. Professor J. Rod, stay methodical, stay curious, and as always, keep tapping into technology. This has been a presentation of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, at gmail.com.